We've found an exoplanet that could harbour life, a black hole that challenges our current understanding of physics and traced the light of the very first stars. Get ready for the 12 most mind-blowing discoveries of the year 2024. Winds on WASP 127b. Earth's hurricanes are fierce, but they pale in comparison to the winds raging on WASP 127b, a puffy gas giant over 500 light-years away. Using the European Southern Observatory's Very Large Telescope, ESO's VLT, astronomers have discovered equatorial winds tearing across the planet at 33,000 kilometers per hour, nearly 27 times faster than the strongest hurricanes on Earth. Slightly larger than Jupiter, but far less massive, WASP 127b was first discovered in 2016, and astronomers have been investigating its extreme weather ever since. Its lightweight, fluffy nature belies its extreme weather, supersonic jet streams racing around the planet. These findings don't just redefine extreme weather, they provide rare insights into atmospheric patterns on distant worlds. Once again, the cosmos reminds us of its astonishing variety. From diamond rain to molten lava oceans, planets like WASP 127b push the limits of our understanding, showing us that in the universe there's always more to discover. K218b, a new hope in the search for life. K218b, a sub-Neptune exoplanet 120 light-years away in the constellation Leo, has revealed compelling clues in its atmosphere thanks to the James Webb Space Telescope. Detected molecules include methane, carbon dioxide, and a potential trace of dimethyl sulfide, DMS, a compound on Earth linked to life, produced by marine phytoplankton. Orbiting in its star's habitable zone, K218b might be a Hycean world with a hydrogen-rich atmosphere and a possible ocean-covered surface. While the ocean could be too hot for life as we know it, the chemical signatures suggest processes worth exploring. By analyzing starlight passing through the exoplanet's atmosphere during transit, Webb achieved unparalleled precision, building on earlier Hubble findings. Lead scientist Nikku Madhusudan called the results a promising step toward identifying life on distant worlds. Further observations are planned, offering hope that K218b might help answer the ultimate question: are we alone in the universe? Cosmic cataclysm gravitational waves from neutron star collision. Gravitational waves, ripples in space-time created by massive cosmic collisions, offer a glimpse into the universe's most extreme physics. Detected by LIGO Virgo Cagra, a global network of gravitational wave interferometers, these waves are caused by events like neutron star mergers and black hole collisions. A new study by researchers at the University of Minnesota and international collaborators enhances detection capabilities, allowing alerts to be sent within 30 seconds of detection. This speed helps astronomers pinpoint the wave's origin and study phenomena like neutron star behavior and the production of heavy elements such as gold and uranium. Gravitational wave detectors use L-shaped interferometers to measure space-time distortions with extraordinary precision, comparable to measuring the distance to the nearest star within the width of a human hair. During this fourth phase of observations, from June 2023 to February 2025, significant upgrades have been made to improve the detection of signals. These improvements allow scientists to spot faint waves that were previously undetectable, with an accuracy never achieved before. This means we're able to observe more subtle and distant events in the universe, pushing the boundaries of what we can learn about space. The software can analyze signal shapes, estimate celestial masses involved, and locate events in the sky. These advancements will help scientists study nuclear reactions and understand how heavy elements are forged in stellar collisions. Researchers aim to refine detection methods further after this run, advancing our grasp of the cosmos. Dark matter outpaces normal matter in a massive galaxy cluster collision. Picture two galaxy clusters, each with thousands of galaxies colliding in a cosmic pileup. Here's the twist. Dark matter, the universe's invisible backbone, zooms ahead while normal matter lags behind. This rare phenomenon was spotted in the galaxy Max J0018.5 plus 1626, billions of light-years away. Dark matter, which makes up 85% of the cluster's mass, only interacts via gravity. Normal matter, stars, gas and planets, feels electromagnetic forces slowing it during the collision. Using data from observatories like NASA's Chandra X-ray and Hubble, scientists mapped how these two components move independently. This galactic crash, viewed head-on, showed dark matter speeding at 3,000 kilometers per second, 1% the speed of light, while superheated gas trailed behind, turbulent and shocked. By tracking photons from the cosmic microwave background using the kinetic Sunyaev-Zeldovich effect, researchers measured gas velocities with unprecedented precision. Simulations confirmed this separation of dark and normal matter, offering a unique glimpse into their behaviors. As lead researcher Emily Silic says, "We've opened a new window into studying dark matter's elusive nature." Published in the Astrophysical Journal, this decades-long study reshapes our understanding of the cosmic forces sculpting the universe. James Webb Telescope's stunning discovery. Imagine a time when the universe was just 620 million years old. Astronomers may have glimpsed light from population 3 stars, the universe's very first generation of stars. These cosmic giants, made only of hydrogen and helium, burned hot and bright, some reaching masses over 100,000 times that of our Sun. Thanks to the James Webb Space Telescope, scientists have detected ionized helium, a possible signature of these ancient fireballs. The galaxy in question shows signs of a hybrid mix of these primordial stars and later generations. But other hot cosmic phenomena could mimic this signal. JWST's ability to peer into the early universe is revolutionizing our understanding, and gravitational lensing may soon help magnify individual stars for closer study. If confirmed, this discovery reshapes our understanding of how the elements that created planets and life itself came to be. The hunt for the universe's first light is on, and we are closer than ever to seeing our cosmic origins unfold. The black hole that challenges our current understanding of physics. Imagine a supermassive black hole, LID 568, that devours matter 40 times faster than physics says it should, breaking every rule in the cosmic playbook. Discovered just 1.5 billion years after the Big Bang, it's like finding a skyscraper in a town of tents. This beast consumes matter at record speed, shattering the Eddington limit, the theoretical Mach speed for black hole feeding. It's so voracious that scientists believe it's powered by an unknown mechanism, something we've never seen before. Thanks to NASA's James Webb Space Telescope and Chandra X-ray Observatory, astronomers tracked this monster hiding in a young galaxy. It's pumping out radiation so intense we can barely fathom it. LID 568 challenges everything we thought we knew about black holes. Could this be the missing piece to explain how the universe's cosmic giants grew so quickly? It's proof the universe is far stranger than we ever imagined. The mystery of fast radio bursts just got deeper. Astronomers thought fast radio bursts, those intense millisecond-long radio signals, came from magnetars, the supermagnetized remnants of young stars. But last year, one burst, FRB 202402009A, threw that idea into chaos. Calvin Leung and his team pinpointed this burst's location using the CHIME telescope and some clever code. But when they looked closer, they found something shocking. The signal came from the outskirts of an old massive elliptical galaxy. 11.3 billion years old and completely dead, with no new star formation. Here's the kicker. Magnetars shouldn't even exist there. This galaxy hasn't produced young stars in billions of years. So what's powering these bursts? This is the first FRB found in such an unlikely place, and it's the farthest from its galaxy ever recorded. Now scientists are asking, are magnetars really the source of FRBs, or is something else entirely at play? The universe loves its mysteries, and this one is a game changer. 6 rogue planets are redefining the rules of space. NASA just found 6 rogue planets, worlds floating through space without a star to orbit. These giants are 5 to 10 times the size of Jupiter, and they've got astronomers buzzing. Rogue planets are mysterious. Were they born in isolation like stars, or were they kicked out of young star systems? The James Webb Space Telescope's deep dive into the NGC 1333 cluster has uncovered clues. Here's the twist. These planets might have dusty disks around them, meaning they could form their own tiny planetary systems. Imagine a planet with planets of its own. This discovery confirms 2 ways planets form, either in the gas disks around stars like Jupiter, or alone in space, just like stars. NASA's upcoming Roman telescope will take this hunt even further, using advanced microlensing to track rogue planets across the galaxy. These loner worlds could help us crack the code on how planets, and maybe life itself, are born. The universe just got a whole lot weirder and way cooler. The race to discover super-heavy elements. In the early 1900s, scientists realized atomic nuclei weigh less than their protons and neutrons combined. This leftover mass creates binding energy, and some nuclei, called magic numbers, are extra stable. The ultimate question? Can we reach the island of stability, a region of super-heavy elements that might last longer than a blink? So far, scientists have created elements up to oganesson 118, but they're incredibly unstable, decaying in seconds. The closer we get to neutron number 184, the more stable these elements seem to become. For instance, copernicium 112 lasts less than 1,000th of a second, but with a specific neutron count, it survives for 30 seconds, a big leap in atomic terms. But are truly stable super-heavy elements even possible? Scientists think the island of stability exists, but its exact location and the lifetimes of these elements remain a mystery. Research facilities like GSI Darmstadt and the new HELIAC accelerator are leading the charge to create and study these exotic elements. They're also exploring how they might be forged in cosmic events like neutron star collisions. These discoveries push the boundaries of the periodic table and our understanding of the universe. Stay tuned, because the hunt for the heaviest elements is far from over. Witnessing a supernova in real time. Deep beneath Japan, a giant steel tank filled with 55,000 tons of water and lined with 10,000 sensors awaits one of the universe's rarest events, a nearby supernova. Back in 1987, neutrinos, tiny, near-massless particles, arrived on Earth, carrying secrets from a dying star 168,000 light-years away. They reached us before the supernova's light, giving scientists a head start to study its explosive death. Fast forward to today. The Super Kamiokande detector has been upgraded with gadolinium salts, making it even better at spotting neutrinos and pinpointing their origins. Why is this big? Neutrinos escape collapsing stars faster than photons, so they're like nature's early warning system for a supernova. If a supernova explodes in our galaxy, Super K can now locate it to within 7 degrees of the sky and alert telescopes in minutes. This could let observatories, like the Vera Rubin Observatory, catch the exact moment the supernova's light appears. This real-time combo of neutrino and light data could finally solve mysteries about how stars explode. All we need now is for the universe to play its part and give us the next Big Bang. NASA's Hubble finds water vapor in a small exoplanet's atmosphere. Have you ever wondered what's out there in the great cosmic ocean? Well, astronomers just got a taste of something extraordinary. Using NASA's Hubble Space Telescope, they've found water vapor in the atmosphere of an exoplanet called GJ 9827d. This planet is just twice the size of Earth, but here's the catch. It's as hot as Venus at a sweltering 800 degrees Fahrenheit. Now, why does this matter? Water is the elixir of life as we know it. Finding it in a planet's atmosphere, especially one so small, is a game changer. Could water-rich worlds be more common than we thought? It's possible, but don't start packing your space bags. This planet is far from a tropical paradise. It's more like a steam bath gone wild. Scientists think it might have a hydrogen-rich atmosphere with traces of water, or could even be half water, half rock. And this discovery is just the beginning. The James Webb Space Telescope will soon dive even deeper, searching for carbon-based molecules like methane and carbon dioxide. Each new discovery brings us one step closer to understanding how these alien worlds form and maybe where life could exist. This planet orbits a red dwarf star, 97 light-years away, in the constellation Pisces. So, keep looking up, because the universe is brimming with secrets waiting to be uncovered. Firefly sparkle, a glimpse at the Milky Way's baby twin. Ever wondered what the Milky Way looked like when it was just a cosmic baby? Meet the Firefly sparkle, a newly forming galaxy spotted by NASA's James Webb Space Telescope. And guess what? It's like looking at a baby picture of our own galaxy. This glittering galaxy, with 10 distinct star clusters, began forming around 600 million years after the Big Bang. Right when the Milky Way was also coming to life. It's cocooned in a glowing arc like fireflies dancing on a summer night. What's mind-blowing? Its mass is similar to what the Milky Ways might have been at the same stage. Most galaxies we've seen from this era are way bigger, making the Firefly sparkle a rare gem. Thanks to these stunning images, we're getting our first glimpse into how galaxies like ours took shape. And it's not just one Big Bang. This tiny galaxy is alive with different phases of star formation happening all at once. This discovery, led by a Wellesley College team, is a cosmic jackpot. These images are the closest we've come to watching a galaxy grow up. So keep your eyes on the stars, because the Firefly sparkle is just the beginning of what the universe has to teach us. New type of cosmic ray detected. Astronomers have just discovered a brand new class of cosmic X-ray sources called Milky Way. Using data from 20 years of sky watching, researchers spotted 29 unusual objects in the Magellanic Clouds, 2 satellite galaxies of the Milky Way. Here's what's wild. These objects experience massive outbursts, brightening by 10 to 20 times their usual levels, and then fading away over months. One of them, Ogham Nova 11, even reached temperatures of 600,000 degrees Celsius. That's over 100 times the luminosity of the Sun. So what are millinovae? They're binary systems where a white dwarf, a dense stellar remnant, orbits a subgiant star. Material flows from the subgiant onto the white dwarf, creating intense X-ray bursts. But here's the fun part. The exact mechanism behind these X-rays is still a mystery. Some scientists think it's thermonuclear explosions on the white dwarf's surface, which could help us solve one of astronomy's biggest puzzles, how type Ia supernovae form. And these supernovae are critical. They're the cosmic rulers we use to measure the universe and were key to discovering its accelerating expansion. Millinovae might just be the missing link to understanding these cosmic explosions. This discovery is another reminder. When we look up, the universe never stops surprising us. Thanks for watching. For more out-of-this-world wonders, hit that like button, subscribe, and don't forget to hit the bell so you never miss a space story. See you in the next video.